For ages, we've branded these black-feathered birds as omens of darkness or a witch's sidekick, completely missing the fact that their intellect can actually outclass us in more ways than one. Join your planet as we dive into the mind-blowing wisdom of the crow and see for yourself if I'm giving them a little too much credit or if they really are the geniuses of the sky. For a long time in biological history, the academic world was stuck in an outdated mindset. They assumed that intelligence was a VIP privilege reserved only for large brains with the complex folded neocortex found in mammals. However, birds and mammals actually branched off from a common ancestor about 320 million years ago, leading to two completely independent evolutionary paths for the brain. In mammals, we take pride in our neocortex, a layered structure specialized for high-level tasks like language and abstract thought. Birds, lacking this specific structure, were historically dismissed as lesser creatures, giving rise to the derogatory term bird brain to describe someone lacking in wit. But a groundbreaking study published in the journal Science in 2020 flipped this script entirely. Using 3D polarized light imaging, scientists discovered that the pallium in a bird's brain isn't just a disorganized mass of cells. Instead, it contains nerve fibers and microcircuits organized in a highly sophisticated geometric map with vertical and horizontal connections woven together. This structure is strikingly similar in function to the human neocortex, allowing data to be transmitted and processed at lightning speeds. It creates the foundation for superior intelligence without the need for a massive brain. We realize that absolute skull size isn't the best yardstick for smarts. And in 2016, a study at Vanderbilt University revealed a shocking statistic. The corvidae family crows, ravens, and their kin possesses twice as many neurons in their forebrain as primates with similarly sized brains. Specifically, even though a crow's brain weighs only about 10 to 15 grams, it packs nearly 1.5 billion neurons. That's effectively the same count found in some large monkeys that are many times their size. This high-density packing offers a massive evolutionary edge. Shorter distances between neurons mean faster electrochemical signaling, giving crows incredibly sharp reflexes and logical reasoning. Instead of developing a bulky brain that would make flight difficult, evolution opted for maximum processing power in a minimalist space. Because of this, crows can tackle multi-layered cognitive tasks from facial recognition to complex tool-making with ease and efficiency. Beyond the technical specs of their anatomy, crow intelligence is heavily nurtured through a unique parenting strategy. While most birds push their young out of the nest to fend for themselves after just a few weeks, the New Caledonian crow, the Einstein of the family, maintains an incredibly tight family bond. Young crows often stay with their parents for up to 2 years. This is a golden window where they don't just receive protection and steady meals, but more importantly, they attend a literal culture school. They spend thousands of hours meticulously observing their role models, their parents performing high-level survival skills. They watch how parents select materials, strip leaves, and bend twigs to craft sophisticated hooks for hunting grubs. This is vertical knowledge transmission, a primitive form of culture that allows the next generation to inherit a lifetime of experience without having to reinvent the wheel. The perfect combo of a compressed, high-performance brain and a long childhood full of learning has produced creatures with a capacity for logic and creativity that we once thought was uniquely human. However, no matter how impressive the theories and anatomical data are, they remain just talk until they are tested in the field. To truly grasp the scale of this intellect, we need to watch them face off against brutal experimental challenges to prove why a crow can sometimes outsmart a 7-year-old child when it comes to solving a problem. Was intentionally kept low, making the prize unreachable for the crow's beak. What stunned the experts was the bird's immediate and decisive reaction. Without any prior training or coaching, these crows quickly gathered nearby pebbles and dropped them into the tube one by one. Each action was followed by a meticulous observation of the rising water level, demonstrating a profound understanding of water displacement, a fundamental concept in physics. To rule out the possibility that this was just a random trial and error behavior, researchers presented the crows with a tougher choice: one tube filled with water and another filled with fine sand. After sizing up the situation, the test subjects completely ignored the sand tube. They seemed to realize that the structure of sand doesn't allow for the same displacement needed to push a liquid upward. It was evidence of a complex mental model, where the animal simulates the laws of the physical world in its mind before ever making a move. To push the crow's quantitative and qualitative thinking even further, scientists upped the ante by providing objects with different physical properties, heavy items that sink and lightweight items that float. In every trial, the crows showed an absolute preference for heavy objects like stones or solid metal pieces while completely bypassing foam, cork, or light wood. This distinction proves that crows understand that only objects with a higher density than water can sink to the bottom and actually change the volume within the vessel. Researchers set up 2 tubes with different starting water levels. The crow made a practically mathematical choice. It chose to drop stones into the tube with the higher water level first. This proved the crow could calculate the workload. Crow knew the higher water level required fewer pebbles and less time to bring the reward within reach. According to analytical reports, this ability to reason through volume, gravity, and density is equivalent to the cognitive stage of a 5 to 7-year-old child. It's a staggering comparison that blurs the intellectual line between animals and humans in basic logic puzzles. The real leap that sets new Caledonian crows apart from the rest of the avian world is compound tool construction, an ability we once believed belonged solely to humans and the highest primates. In a strictly controlled environment, biologists designed a puzzle box with food hidden deep inside a narrow crevice where the short sticks available were too stubby to reach. Instead of giving up, the crow performed a feat of engineering. It picked up a hollow plastic tube and skillfully inserted a small wooden stick into the end to extend its reach. This was creating a new tool from separate parts. The peak of this astonishment came when one individual crow was recorded successfully combining 3 and even 4 separate pieces to create a pole long enough to snag the bait. Understanding that short objects can be combined along a vertical axis to create a new functional entity requires spatial imagination and multi-step problem solving. In the history of wildlife observation, aside from humans and a handful of adult chimpanzees, almost no other creature has performed such a complex technical feat, making the crow a true engineer of the sky. As impressive as these feats of physical analysis and mechanical engineering are, they only paint part of the intellectual picture. True intelligence isn't just about applying physical laws to solve the problems right in front of you. It requires the ability to detach from the immediate needs of now and look toward the future. A high-intelligence being must know how to control its immediate impulses and suppress the reward system in its brain to plan and execute calculated actions for bigger, more important goals down the road. This is the final frontier that solidifies the crow's standing at the very top of the animal kingdom's intellectual ladder. In much of the animal kingdom, behavior is driven by immediate survival instincts. When they feel hunger, they eat whatever is available. When they face danger, they bolt. However, establishing a long-term plan is a cognitive masterpiece, requiring a seamless blend of 2 high-level mental faculties: retrospective memory of the past and prospection for the future. A groundbreaking study published in the journal Science in 2020 utilized a sophisticated experimental design to test this very capacity in ravens. Initially, the ravens were trained to understand the mechanics of 3 entirely different puzzle boxes, each of which could only be activated by a specific tool. To challenge their patience and memory, researchers removed the ravens from the lab for a 5-minute break after they had seen only one specific box. Upon their return, they were presented with 5 objects: the tool compatible with that box, 2 tools for the other boxes, and 2 useless distractions. The results were stunning. Not only did the ravens select the correct tool based on short-term memory, but they also demonstrated mental time travel by choosing to hold on to that item and wait through an additional 10-minute delay. They logically understood that while the item offered no immediate benefit, it was the only way to secure a lavish dinner 15 minutes later, a planning capability that scientists previously believed was unique to humans and great apes. The complexity of crow cognition reached a fever pitch during the delayed gratification test, an experimental model similar to the famous Stanford marshmallow experiment used to measure self-control in children. Researchers placed the crows in a tempting dilemma. On one side was a small, immediate snack, like a low-value piece of bread or a seed, and on the other was a mediator tool that would unlock a box containing much higher quality rewards, like fresh meat or nutrient-dense nuts. Faced with the direct stimulation of food, most creatures surrender to instinct and consume the lesser reward immediately. Yet, crows consistently opted for the tool, choosing to suppress their hunger and the dopamine-driven excitement of the brain's reward system to make a long-term investment for a better payoff. This isn't just simple smarts, it is a manifestation of executive function located in the forebrain. In humans, this ability only begins to take shape around age 5 and remains notoriously unstable well into adulthood. The fact that a bird can consistently perform this trade-off shattered old assumptions about the limits of the avian nervous system, proving they possess the ability to calculate marginal utility with extreme precision. Beyond the confines of the laboratory, crows reveal their genius for planning through survival behaviors in the wild, particularly in food caching. They never hide food haphazardly or at random. Instead, every action is a psychological chess match. If a crow senses it is being watched by an onlooker, another crow, or a competitor while hiding seeds, it will engage in elaborate deceptive maneuvers. It might pretend to dig and cover a fake spot while actually concealing the prize in a completely different location, if their actions accordingly to protect their assets. This is the pinnacle of calculated deception, showcasing a razor-sharp level of social intelligence. The synergy of a complex inner life, time management, and strategic calculation has turned crows into the architects of their own lives. However, their intellect isn't just confined to physics puzzles or dry bits of food. Their world expands into a dramatic and nuanced social network. Within that network, personal relationships, political alliances, and even lifelong vendettas have created a unique avian culture. This social intelligence is the final piece of the puzzle that explains why crows stand at the peak of the evolutionary ladder, becoming the primates with feathers that dominate the skies in their own right. The ability to navigate complex social webs has long been hailed as the hallmark of a highly developed brain, typically reserved for tight-knit groups like orcas or chimpanzees, societies where every individual must constantly play politics to maintain their standing. However, the crow family has proven to be just as shrewd in these calculated power games. Their adolescent phase is particularly fascinating. Before finding a lifelong mate to bond with, young crows congregate in communities that biologists humorously refer to as juvenile gangs. In reality, these gangs serve as a high-stakes social proving ground. Here, they relentlessly hone survival skills and establish a pecking order through food squabbles and impressive aerial acrobatics. To thrive and climb the ranks within this system, a crow's brain must function like a massive database, cataloging the specific traits of every other individual. Who is the powerful leader to be feared? Who is the underdog to be bossed around? And most crucially, who can be a trusted strategic ally? Studies indicate that crows can track the social status of dozens of different individuals and calibrate their behavior for maximum benefit, a clear testament to their superior emotional intelligence and social mapping. Stretching far beyond their own kind, a crow's memory and recognition skills extend to entirely different creatures, most impressively, humans. A famous multi-year study at the University of Washington produced staggering conclusions about their memory. Researchers conducted an experiment wearing villainous masks while briefly capturing and banding crows before releasing them back into the wild. The result was a deep-seated, collective grudge. Years later, whenever anyone stepped onto campus wearing that specific mask, the entire flock would instantly trigger an alarm system with piercing shrieks. They didn't stop at noise. They organized disciplined, coordinated attacks, diving and defecating with pinpoint accuracy to drive the target away. Most shocking to the researchers was that even young crows, or those that had never been captured, joined the fray with gusto. This proves that crows possess an incredibly efficient communication network. They can learn through observation and pass down information about threats to the community without needing first-hand experience. That 5-year grudge is merely a baseline. Field evidence suggests these vendettas can last a lifetime and may even be handed down to the next generation as a vital survival lesson. Crows don't just classify humans as friends or foes, they also exhibit a unique capacity for interspecies interaction with apex predators, specifically gray wolves. In the closed ecosystem of Yellowstone National Park, field observations have captured remarkably human moments. Crows actively initiating play with wolf pups. They engage in games like tug-of-war with old bones or mischievously nip at a wolf's tail to bait them into a harmless chase. Far from being random entertainment, these behaviors are a highly intelligent trust-building tactic, refined over thousands of years of evolution. By forging close ties with the pack from a young age, crows essentially secure a VIP pass to scavenge high-quality leftovers from wolf kills without the risk of being attacked. In return, the crows serve as aerial scouts, spotting prey from a distance or sounding early warnings about threats like bears or hunters using specific vocalizations. This level of empathy and the ability to build symbiotic relationships based on cross-species trust is the smoking gun proving that crows are not just logical math whizzes, but masters of behavioral psychology, strategic cooperation. This extraordinary intellect has blazed new trails for collaboration between humans and these clever birds. Today, several ambitious real-world projects are underway, such as programs in major parks in France and the Netherlands, where crows are trained to act as eco-warriors. They collect plastic waste or cigarette butts in exchange for treats from automated dispensers. When you look deep into the sharp obsidian eyes of a crow, you aren't just seeing a bird. You're looking at an independent thinker, an intellect that has quietly evolved alongside humanity for millions of years to reach this breathtaking level of maturity. Studying and deeply understanding crows doesn't just open a door to the animal kingdom. It acts as a mirror, helping us decode the deepest mysteries of how the brain functions. It forces us to reevaluate and humbly redefine the human position, as well as our symbiotic relationship with every other living creature, in the grand and glorious tapestry of life on Earth. So, what can we really learn from the crow? In the natural world, few creatures suffer from as many prejudices as the crow. With plumage as dark as night and a raspy caw often regarded as an omen of misfortune, crows have frequently appeared in culture as somber, eerie beings. However, behind this controversial exterior lies one of the most brilliant minds on the planet. Modern scientists refer to crows as feathered primates because they possess cognitive abilities, problem-solving skills, and complex social structures that rival those of great apes or dolphins. By observing and studying these birds, we discover not only the wonders of evolution but also profound lessons about thinking, perseverance, and how humans should interact with the world around them. The first lesson crows offer is flexibility and the ability to think outside the box. New Caledonian crows do not simply pick up a twig to poke at food. They know how to strip leaves and bend the end of a branch into a hook to retrieve larvae hidden deep within tree hollows. If a tool is too short, they understand how to join multiple segments together to create a longer implement. In life and work, resources are often finite, and crows teach us to focus on solutions rather than complaining about conditions. The ability to adapt and creatively use what is readily available is the key to survival in a constantly changing world. True intelligence does not lie in what you possess, but in how you utilize it to overcome adversity. Furthermore, the crow is a living testament to the value of perseverance and the ability to delay gratification. Psychological experiments have proven that crows possess incredible self-control, as they are willing to reject a sunflower seed immediately to wait 15 minutes for a better piece of meat. In an era of instant gratification, where everything from food to success is expected to be rapid, the crow reminds us of the importance of a long-term vision. Great achievements usually belong to those who can control immediate impulses to invest in loftier goals. Patience here is not passivity, but a high-level cognitive strategy aimed at optimizing future benefits. The intellectual development of crows also stems from a foundation of sustainable education and cultural inheritance. Young crows often stay with their parents for up to 2 years, an exceptionally long period for a bird to participate in a veritable school. Here, they observe their parents crafting tools and learn to identify specific dangers. This demonstrates the vital importance of knowledge transmission. No matter how intelligent an individual is, they can hardly progress far if they must start everything from scratch. Crows teach us that the bond between generations and the spirit of learning from those who came before are the foundations of sustainable growth, reminding humans to cherish education and build communities where knowledge is shared rather than lost. Additionally, crows possess a sharp social intelligence through their ability to understand their rivals. They can perceive the thoughts and intentions of others, as evidenced by their behavior of faking, where they hide food to mislead onlookers. In communication and negotiation, understanding the perspective of the opposing party is paramount. This lesson of observation and strategic empathy from the crow reminds us that success comes not only from technical expertise but also from sensitivity in social relationships. Knowing how to put oneself in another's shoes, whether they are an ally or a rival, helps us make informed decisions and protect our achievements. Finally, the crow teaches us about humility and the ability to harmonize with nature. Despite their superior intelligence, they do not seek to dominate their environment, but choose intelligent symbiosis, such as acting as aerial scouts for wolves or utilizing traffic lights to have cars crack open hard nuts. Humans often consider themselves the pinnacle of creation, but the crow shows that true wisdom lies in the ability to adapt and coexist harmoniously. Every creature on Earth carries its own intelligence and a respectable position. We should look at the crow with the respect of a student. They have flourished not through physical brawn, but through the power of connection, observation, and continuous learning. Learning from the crow is learning how to become a more resilient and insightful version of ourselves. So, what do you think? Is all that enough to change how you look at these birds? Or are you still seeing them the same way as before? We'd love to hear your thoughts in the comments below. Also, don't forget to suggest any topics you're curious about, whether it's more secrets of the natural world or the amazing creatures all around us. We'll continue our journey in the next videos. Goodbye for now, and see you soon.